In geotechnical engineering, a caisson is a watertight retaining structure used, for example, to work on the foundations of a bridge pier, for the construction of a concrete dam, or for the repair of ships. These are constructed such that the water can be pumped out, keeping the working environment dry. When piers are to be built using an open caisson and it is not practical to reach suitable soil, friction pilings may be driven to form a suitable sub-foundation. These piles are connected by a foundation pad upon which the column pier is erected. How caissons work. Shallow caissons may be open to the air, whereas pneumatic caissons, which penetrate soft mud, are sealed at the top and filled with compressed air to keep water and mud out at depth. An airlock allows access to the chamber. Workers move mud and rock debris from the edge of the workspace to a water-filled pit, connected by a tube to the surface. A crane at the surface removes the soil with a clamshell bucket. The water pressure in the tube balances the air pressure, with excess air escaping up the muck tube. The pressurized airflow must be constant to ensure regular air changes for the workers and prevent excessive inflow of mud or water at the base of the caisson. Installation. To install a caisson in place, it is brought down through soft mud until a suitable foundation material is encountered. While bedrock is preferred, a stable, hard mud is sometimes used when bedrock is too deep. Dangers encountered in pressurized caissons. Caisson disease has been named since it appeared in construction workers when they left the compressed atmosphere of the caisson and rapidly re-entered uncompressed atmospheric conditions. It is caused by the same processes as decompression sickness in divers. Construction of the Brooklyn Bridge, which was built with the help of caissons, resulted in numerous workers being either killed or permanently injured by caisson disease during its construction. Barotrauma of the ears, sinus cavities and lungs, and dysbaric osteonecrosis are other risks. Other uses. Caissons have also been used in the installation of hydraulic elevators where a single-stage ram is installed below the ground level. Caissons, codenamed Phoenix, were an integral part of the Mulberry Harbours used during the World War II Allied invasion of Normandy. Types. The four main types of caisson are box caisson, open caisson, compressed air caisson and monolith caisson. Box caisson is a prefabricated concrete box. It is set down on prepared bases. Once in place, it is filled with concrete to become part of the permanent works, such as the foundation for a bridge pier. Hollow concrete structures are usually less dense than water, so a box caisson must be ballasted or anchored to keep it from floating until it can be filled with concrete. Sometimes elaborate anchoring systems may be required, such as in tidal zones. Adjustable anchoring systems combined with a GPS survey enable engineers to position a box caisson with pinpoint accuracy. An open caisson is similar to a box caisson, except that it does not have a bottom face. It is suitable for use in soft clays, but not for where there may be large obstructions in the ground. An open caisson that is used in soft grounds or high water tables, where open trench excavations are impractical, can also be used to install deep manholes, pump stations and reception launch pits for micro-tunneling, pipe jacking and other operations. A caisson is sunk by self-weight concrete or water ballast placed on top, or by hydraulic jacks. The leading edge of the caisson is sloped out at a sharp angle to aid sinking in a vertical manner. It is usually made of steel. The shoe is generally wider than the caisson to reduce friction, and the leading edge may be supplied with pressurized bentonite slurry, which swells in water, stabilizing settlement by filling depressions and voids. An open caisson may fill with water during sinking. The material is excavated by clamshell excavator bucket on crane. The formation level subsoil may still not be suitable for excavation or bearing capacity. The water in the caisson balances the upthrust forces of the soft soils underneath. If dewatered, the base may pipe or boil, causing the caisson to sink. To combat this problem, piles may be driven from the surface to act as load-bearing walls, in that they transmit loads to deeper soils; anchors, in that they resist flotation because of the friction at the interface between the surfaces and the surrounding earth into which they have been driven. H-beam sections may be driven at angles, raked to rock or other firmer soils. The H-beams are left extended above the base. A reinforced concrete plug may be placed under the water, a process known as tremi-concrete placement. When the caisson is dewatered, this plug acts as a pile cap, resisting the upward forces of the subsoil. Compressed air. A compressed air caisson has the advantage of providing dry working conditions, which is better for placing concrete. It is also well suited for foundations for which other methods might cause settlement of adjacent structures. Monolithic. A monolithic caisson is larger than the other types of caisson, but similar to open caissons. Such caissons are often found in quay walls, where resistance to impact from ships is required. Boat lift caissons. The word caisson is also used as a synonym for the water-filled trough part of caisson locks. Canal lifts and inclines in which boats and ships rest whilst being lifted from one canal elevation to another. This is the opposite to the caissons mentioned earlier. The water is retained on the inside of the caisson, not excluded from the caisson. Structural caissons. Caisson is also sometimes used as a colloquial term for a reinforced concrete structure formed by pouring into a hollow cylindrical form, typically by placing a caisson form below grade in an open excavation and pouring once backfill is complete, or by drilling at grade. Although this can be problematic with deep caissons, as unsupported excavations can collapse before the caisson form can be inserted. In this manner, the earth placed around the empty caisson form provides stability and strength, allowing concrete to be poured with fewer complications and with less risk of a form blowout. While technically only the form itself is actually a caisson, it is not uncommon for any below-grade cast concrete pillar to be referred to as simply a caisson. Ventilation filtration systems. The word caisson is also used as a name for an airtight housing for ventilation filters in facilities that handle hazardous materials. The housing usually has an upstream compartment for a pre-filter element and a downstream compartment for a high-efficiency filter element. It may have multiple sets of compartments. The housing has gasketed access doors to allow for the change out of the filter elements. The housing is usually equipped with connection points used to test the efficiency of the filters and monitor changes in the differential pressure across the filter media. Patents. U.S. Patent 123,002, improvement in construction of subaqueous foundations.